All right, guys, in section 1.6, we are going to talk about applying trig functions to angle of rotation. So quick refresher, and we're going to be using these two special triangles over and over and over again in this section. So for a 45, 45, 90 right triangle, the ratios of the sides will be x, x, and x radical 2. In other words, if you just divide all these by x, then this gives you 1, 1, and radical 2. Same thing over here. For 30, 60, 90, we have x, x radical 3, and 2x. If you divide all these by x, then this gives you 1, radical 3, and 2. So for a 45, 45, 90, opposite of 45 and 45, it'll be 1 and 1, and opposite of 90 will be radical 2. For a 30, 60, 90, opposite of 30 will be 1, opposite of 60 will be radical 3, and opposite of 90 will be 2, as you can see here. Now, a reference angle is going to be something we're going to be using throughout the semester. So what is a reference angle? A reference angle is formed by the terminal side of the angle and the x-axis. This is super important. Okay, sometimes students get that wrong and they use the y-axis. It's always going to be the x-axis. So for any given angle, a reference angle is going to be formed by the terminal side, so it would be the side in blue, and the x-axis. So we're always going to go down to the x-axis, and this is going to be a reference angle. The reference angle, which is also called theta prime, sorry, don't know what happened there. The reference angle, which is also called theta prime, can be used to find the 6 trigonometric functions of theta. So the cool thing is that theta and its reference angle theta prime have the exact same trigonometric values. So how do you find trigonometric functions using reference angles? Well, step 1, you sketch theta. Step 2, find the reference angle. This is super important. By making a right triangle with the terminal side and the x-axis, I'm going to keep emphasizing this, and then fill in the ratios for each of the sides. For example, let's take 120 degrees. So for 120 degrees, we're going to sketch the angle. So this is your initial side, and 120 is going to be 90 plus 30. Okay, this is going to be 120 degrees. A reference angle is going to be the angle that's made with the terminal side and the x-axis. Don't forget that. It always goes to the x-axis. So this is going to be our reference angle theta prime. Now that angle, if this is 30, we know that these two angles together make 90. So if this is 30, then our reference angle is going to be 60 degrees. This will be our reference angle theta prime. Now, step 3 is fill in the ratios for each of the sides. So if this is 60, we know that this is going to be 30. And opposite of 30 is 1, opposite of 60 is radical 3, and opposite of 90 is 2. Whenever we go in the negative direction, so because we're going in the negative direction, this will be a negative 1. Okay, so let's find the 6 functions. Sine of 120 is going to be the same as sine of theta prime. So sine of theta prime is going to be opposite over hypotenuse, which is going to be radical 3 over 2. Cosine of 120 is going to be cosine of theta prime, which is going to be negative 1/2, adjacent over hypotenuse. And then tangent of 120 is going to be opposite over adjacent, so that's radical 3 over negative 1, which is just going to be negative radical 3. Now let's take the reciprocal functions. Let's take the cosecant of 120 degrees. If you flip this, we're going to get 2 over radical 3. Now, refresher, we cannot have a radical on the denominator. So to get rid of the radical, we use something called rationalizing. So if you have a radical 3, to get rid of it, we multiply by another radical 3. So this gives us 2 times radical 3, which is radical 3 on the numerator, and radical 3 times radical 3 will just be 3 on the denominator. So cosecant of 120 is going to be 2 radical 3 over 3. Okay, now let's take the secant. I'll write that up here. I know I'm running out of space here. Secant of 120. So if the cosine is negative 1/2 and you flip that, the secant is going to be negative 2 over 1, which is negative 2. And then lastly, cotangent of 120. We take the tangent of 120, which is radical 3 over negative 1. That's negative radical 3. And you flip that. You take the reciprocal of it, which is going to be negative 1 over radical 3. Now, same thing. We cannot have a radical on the denominator. So if I multiply both of these by radical 3, this is going to give me negative radical 3 over 3, and that'll be the cotangent of 120. You know what? I probably should have made more space for this. I'm sorry. Let's do 225. So first step is to sketch 225. So we got 90 plus 90 is 180 plus 45. That gives us 225. Now, how do you make our reference angle? We're going to take the terminal side, and I'm going to keep repeating this over and over again until you get sick of it. I'm going to take the terminal side and make a triangle with the x-axis. So my theta prime is going to be 45 degrees. So that makes this a 45, 45, 90 right triangle. Now, what are my ratios? Opposite of 45 is 1, opposite of 45 is 1, and the hypotenuse is radical 2. Anytime you go in the negative direction, that's going to be negative. So we have a negative 1 and a negative 1. Notice that the hypotenuse is always going to be positive. These are negative because you're going in the negative x and the negative y direction. All right, I'm going to start up here. So the sine of 225 is going to be opposite. So now we're looking at theta prime. So opposite of theta prime is negative 1 over the hypotenuse, that's radical 2. We need to rationalize it, so we have to multiply both the numerator and denominator by radical 2. This gives us negative radical 2 over 2. This is the sine. Cosine of 225 is going to be adjacent, which is negative 1 over radical 2. Same exact thing. You rationalize it and get negative radical 2 over 2. That'll be the cosine. Tangent of 225. Tangent of 225 is going to be opposite over adjacent. So theta prime, that's the angle we're looking at. Opposite over adjacent is negative 1 over negative 1, which is just going to be 1. Now down here, I'm going to say what is my cosecant. So I want to say cosecant of 225. Now for cosecant of 225, I'm not going to take the rationalized form. I'm going to take this form right here, the negative 1 over radical 2. And I'm going to flip that. So take the form before rationalizing. If I flip that, if I take the reciprocal of it, that gives me negative radical 2 over 1. And that's just negative radical 2. All right, secant of 225. Same exact thing. If cosine is negative 1 over radical 2 and I take the reciprocal of that, that'll just give me negative radical 2. Same thing as cosecant. And then cotangent of 225 should be even easier. If tangent is 1, the reciprocal of 1 is still 1. So cotangent of 225 will equal to 1. Now 330, we're going to do this one in class. Let's take another example, negative 120 degrees. So negative 120, if I sketch that, this is going to be negative 90 and negative 30. It's going to be this angle right there. That's negative 120. So what I want to do is I want to take a reference angle. So I'm going to take the terminal side and go up to the x-axis. And this is my theta prime. That's my my reference angle. So if this is 30, then my theta prime has to be 60, because 30 and 60 have to make 90. So I have a 30, 60, 90 right triangle. Now remember, opposite of 30 is always going to be 1, but because we're going in the negative direction, it'll be negative 1. Opposite of 60 is always going to be radical 3, but because we're going in the negative direction, that'll be negative radical 3. And opposite of 90 is always going to be 2. Okay, so now let's go ahead and solve this. So if I have sine of negative 120, remember, sine of negative 120 will be the exact same as the sine of the reference angle, which is theta prime. Sine is opposite over hypotenuse. That's going to be negative radical 3 over 2. Cosine of negative 120 will be the exact same as the cosine of theta prime. That's adjacent over hypotenuse. That's in negative 1/2. And then tangent of negative 120 is going to be opposite over adjacent. This will be negative radical 3 over negative 1, which is going to be a positive radical 3. All right, let's take the reciprocals. Let's take the cosecant. So cosecant of negative 120, if I take the reciprocal of this, that'll be negative 2 over radical 3. I have to rationalize this because I can't leave a radical on the denominator. So if I multiply these both by radical 3, this gives me negative 2 radical 3 over 3. Then I have secant of negative 120. So cosine of negative 120 is negative 1/2. If I take the reciprocal of that, that'll be negative 2 over 1, which is just negative 2. And then cotangent of negative 120. Again, I'm taking the cotangent of the reference angle. So tangent is negative radical 3 over negative 1. If I take the reciprocal of that, it's going to be 1 over radical 3. And to rationalize it, I multiply both the numerator and denominator by radical 3. This gives me radical 3 over 3. Okay, let's take the next one, negative 240. So we start at the x-axis, negative 240, so this is going to be negative 90. That's going to be negative, now that's negative 180. And then I have to go 60 more. I have to go negative 60 more to get to here. So this is negative 240 degrees, a negative 90, and negative 60. This gives me negative 240. My reference angle is going to be made with my terminal side and the x-axis. So I go down to my x-axis. In my theta prime, even though I'd use negative 60 to go, to measure, I still take the positive value of that. So my theta prime is going to be 60 degrees. So up here is going to be 30 degrees. All right, now let me put in my ratios. So opposite of 30 is going to be 1, but it's going in the negative direction, so it's negative 1. Opposite of 60 is going to be radical 3, and opposite of 90 is going to be 2. All right, let's write our ratios. Start with sine. Sine of negative 240 is going to be the sine of the reference angle theta prime. So sine is opposite over hypotenuse. That's going to be radical 3 over 2. Cosine of negative 240 is going to be adjacent over hypotenuse. That's negative 1/2. And then tangent of negative 240 is going to be opposite over adjacent. That's radical 3 over negative 1, which is negative radical 3. Let's take a look at cosecant. Cosecant of negative 240 is going to be the reciprocal of sine. So if I take radical 3 over 2 and I flip it, it's 2 over radical 3. And if I rationalize that, I'm multiplying both the numerator and denominator by radical 3. And then this will give me 2 radical 3 over 3. Secant of negative 240 is going to be the reciprocal of cosine. If my cosine is negative 1/2 and I flip that, this gives me negative 2 over 1. And the cotangent of negative 240, if I flip radical 3 over negative 1, this gives me negative 1 over radical 3. I rationalize that, so I multiply both the numerator and denominator by radical 3, and this gives me negative radical 3 over 3. Now this one we will do in class.